Hello everyone, and welcome to today's presentation on how to visualize advanced analytics using the R programming language. My name is Nikhil and I'm the solution architect with Dundas Data Visualization, and I'm excited to walk you through today's presentation. We will focus on what is our programming language, and we'll also walk you through the live demonstration of how to integrate our language within Dundas BI, and we'll talk about how to better visualize it in a more meaningful way within the application. Now, before we get started, just a brief history on our company. Dundas has has over 20 years of experience in data visualization and the business intelligence space. Our current product, Dundas BI, is the result of our continued innovation and improvements based on the feedback that we receive from our clients. With all of our products, we've always focused on making 80% of our use cases easy and the remaining 20% possible by ensuring that you can solve both simple as well as advanced problems. The main reasons why customers choose us are rooted in our ability to deliver on any solution requirements without having to involve many tools, and for being able to easily scale it up to the enterprise as well as outside of it. Our customers also love us for our innovative interactive visualizations, which has always been at the core of our Dundas products, allowing simple consumers to better understand data. Another key point for our customers is that they don't just get a product, but they also get a close support and partnership, ensuring that they're able to solve their real problems. Now, Dundas BI provides all your business intelligence needs under one roof, where you can bring in the data from any source and start either preparing it and visualizing it directly from the data source in a real-time data access, or you can also prepare it inside the data preparation layer before presenting it in a visual way. You can also have the ability to not just visualize the data in a real-time basis, but also store them inside the in-memory as well as inside the data warehouse. Now, in terms of how to implement R, that is where the data preparation layer also comes into play, where you bring in the data from wherever the data source is, and you use the R programming language within the preparation layer and present that in a more meaningful visual way. Now, as I mentioned, the application is designed to cover your end-to-end BI needs in a single platform that sits on top of your data sources, including data preparation, analytics, custom presentation, collaboration, governance, and all within an extensible platform which is built entirely upon the latest web standards. Now, what is R? R is an open source programming language which is freely available online. You can go onto the our website and download it and start using it, and it provides an environment for your statistical computing needs and graphical analysis. It is one of the most widely used software packages for your statistical analysis, primarily because it is open source and it is free, and it provides you with a variety of libraries for statistical testing, classification, clustering, etc. There are about 4,000 specialized packages, and we are going to talk about a few of them today. I'm going to show you how you can import them, how you can utilize them in analyzing the data within Dundas BI. Now, the R itself is also very extensible and allows, there is a whole user community that keeps on adding additional functionality by defining new functions and publishing it into the our libraries. You can also use it for data manipulation, analysis, and visualization. And within Dundas BI, where you utilize R is within the data analytics layer inside what we call a data cube using the R transformation. Now, Dundas BI does offer a lot of inbuilt statistical and financial formulas that you can utilize, but if you want to execute any advanced calculations, such as you want to do clustering, you want to perform correlations, analyze text, regression, outliers, and decision trees and all, that's where you would utilize the power of our language and execute them and get the result and then visualize it. And also combine it um, with your dashboards, reports, and scorecards, and predict the result. You're not just looking at static dashboards, but you're also making predictive analytics, so based on the analysis that you've done using this language. And that's really the power of the language that is R. Now let's take a look at a demonstration of uh, the R integration within Dundas BI. I'm going to walk you through how to use the language within the platform, where to use it, and how to import libraries, and we're also going to see how to visualize them in a more visually appealing way. I'm going to start off with showing you a simple example on how to use a simple formula. Then we'll move on to more advanced calculations. And while I'm walking through the presentation, feel free to ask any of your questions. There is a questions uh, section within your GoToWebinar panel. Just feel free to type in your questions and we'll cover them either as we go along or towards the end we'll have a full Q&A session. So let's jump into the platform and let's take a look at R in action within Dundas BI. Now, the first example that I'm going to show you is just use a simple formula just to calculate a simple median. Here's a median line that's been calculated using R, and I've also highlighted in this case, this chart is highlighting the ratings of these different companies, and using red and green colors you can see which of these companies have performed below median, which of these companies have performed above median. How to implement a chart like this is you open the data cube layer, which is our data preparation layer that allows you to bring in your sources and use the most commonly used data modeling and manipulation tasks in order to prepare the data. Now for R, we have the R language analysis transform that you implement, connect to your data, and implement your R queries within the platform. Here's a simple SQL statement that I've run that queries all the companies and their ratings alongside. Now when you implement the R transform, first thing you do is define the placeholders. By defining placeholders, you just make sure that the name, the column name, you match that with something that the R transform recognizes. And using the R script, you can here I've just assigned those columns to as arguments. You can see that this follows the standard R syntax, so there is no difference. All this is doing is executing the R script on the R server, and you can execute the exact syntax that you use within your R server. So if you're familiar with that, just copy paste that script and you're good to go. One thing that Dundas BI does require is that the output should be in the form of a data frame. So here in this case, I'm just passing the two columns as different arguments and outputting that inside a data frame. And within this data frame, I've used a simple median function, and I've calculated the median of the rating. Now, what this looks like is if I go into the preview, you can see that these are the two columns that are coming from my database, and this is the median calculation. How do you use this? How do you visualize this inside Dundas BI? Is you open the data exploration panel called the metric set, open the data cube. Now, whenever you create your analysis, it gets created as a data cube, and all you do is just drag and drop. So here's the rating, here's the company, and if you want to compare it to a median, just drag and drop the median. So this median is coming from the R language analysis that you've done using the median formula, and if you want to visualize this inside Dundas, all you do is click on revisualize and select from these chart types. That's all. And if you want to just visualize this median chart, just right click, revisualize, and select the type that you want to visualize this as. Now in the first chart that you saw, you also saw that I highlighted some of the data points that have fallen above or below the median, and that's where you can also utilize Dundas BI's features to highlight any outliers that you want to visualize within uh, within your visualization, and that is done using the state analysis. Here, anytime something falls below the median, I want to highlight this on the chart. So this way you can highlight the outliers that you have calculated based on the functions that are coming straight out of R. So this was a simple calculation that I've showed you. Now obviously, like I mentioned, you can utilize the inbuilt formulas to do this kind of a simple calculation like averages, means, medians. Where does R come in? You can obviously calculate these simple functions using R, but also if you want to do some advanced calculations and advanced analysis, that's where the power of R comes into play. Now here's one other example that I'm going to show you where we are actually going to see the clustering prediction using the R. I'm going to use the k-means clustering algorithm that that gets multiple variables and decides how many clusters you want to generate out of those variables. So here's a known cluster at the top, and here's the predicted cluster that you see at the bottom. I'm going to show you how to visualize it in a moment, but let's take a look at the implementation of the k-means clustering algorithm within Dundas BI. Once again, I'm going to open the data cube, and I'm going to open the data cube that does the calculation for me. I'm going to use a simple iris data set that again is coming from the you can download it. It's available online. It's a public data set called Iris that you can straight away download and implement that, import that within Dundas BI and perform your calculations on top of it. It provides you with the sepal and petal length of different species of irises. And using R, what we're going to do is cluster them. And classify them, classify the different data points into different clusters. Now, all I'm doing here is taking all these columns and storing them as arguments within the algorithm, and passing and use the k-means function by passing all these arguments within a data frame and outputting that inside, once again, a data frame where I am going to output all the original columns as well as the result of the cluster. Now what k-means does is it gets those multiple variables and decides how many clusters that you want to generate out of those variables. It randomizes the location of the means of these different clusters, and based on the distance from that mean, it classifies the different data points into that particular cluster. So using R, I've used k-means algorithm to divide my data set into 3 different clusters in this case, and in the data preview you can see that I've made these the cluster and you can see the division of these variables into the different clusters here. Now on my chart, if I just open and expand the dashboard here, you can see that if I add my species, which is coming out of the iris data set directly, you can see the different classification of these 3 different clusters. Now this is the cluster that is known, that you validated this, and now you want to compare this with what's been predicted using the k-means algorithm. So this is a known cluster. This is the one that is coming from the algorithm. So once again, if I open the data analysis panel and add the cluster result here, you can see that both these results are more or less similar, very similar in fact. You can see those three distinct clusters on both the charts here. One of the things that K-means offers or does is that it's not very deterministic. It's not totally deterministic, and the beginning of the algorithm is randomized. So you may not get the same results in the cluster always. So if I go here and refresh the data, you can see that the cluster itself changes as compared to the known cluster. So you may see random results, but the probability of both the results being the same is very high. And once again, it's you have to make sure that the data is validated as with any algorithm, and compare it with the known data models, and you can get as close to the result as possible. Now, in both the examples that we saw, we've seen that we've used the capabilities. We've executed the R script directly in the R server. So what you do is install the R server on inside in your environment, and point Dundas BI to execute the scripts within the R server. But there's also one other way where you can execute the R scripts. If you don't want to use R server, SQL 2016 allows you to execute R scripts within its own environment. Now with 2016, if you install 2016, there is an add-on called the Advanced Analytics add-on that you just need to install on your SQL server, and you'll be able to execute R scripts within it. Within Dundas BI, you can do the same thing. So if let's say you have not installed rserv on your machine, you can still execute R scripts if you have 2016 SQL Server. Now here's an example where I've executed this script directly on using the SQL server. All I'm doing is call the execute stored procedure. This is a standard stored procedure that you need to utilize, and you specify what language it would be executed in. And here I specify that it will be executed in R, and here's the R script. You can see that this is the exact script that we saw previously that I executed within the R server. And the rest of it is just the data that is coming from my SQL database. Here I'm using a manual SQL select statement. Maybe you want to use, you want to pull data out of a database. But the key thing is that you don't have to install R on your machine. If you have 2016 SQL Server, just install the add-on. It's called the Advanced Analytics add-on, and you can execute the script directly within your SQL Server, and you can see that it's the exact same result. Now let's take a look at another example where you're forming correlations between the different variables that are coming out of your data. Now let's say here I have my data set, and this is just a standard empty cars data set that I've imported within the system. And once again, it's an open data set. You can download it online. It's called empty cars. And here, based on each of the car models, it's been you get different categories of the cars, where you can see how much miles per gallon that cars consumes, how many number of cylinders it needs, what the displacement is, the weight of the car. Now, when you're looking at this, it's really hard to make sense of what these variables means and what the relation is between these variables. So let's use the power of R to correlate this data. If I once again go back to my data cube and open the um, R script that does the calculation, here I've directly generated the data using Dundas BI. Now Dundas BI does offer the ability to generate data directly, so if I configure this, you can see that I've executed the R script directly here instead of connecting to an existing database. One of the things that you can do is just like you're using the any of the R environments like RServe or RStudio, you can directly install packages here. Like I've done, I've installed the HMIC package here, and I've loaded the data called empty cars. And once again, this is a standard data set that comes with R, so you can utilize it directly. And I've stored this within a data frame here, and I'm using the HMIC library to call the R core function, which calculates the correlation for me. And one of the things that this function does is that it returns a matrix of the data. Now, in order for Dundas BI to be able to visualize it, you need to make sure that you flatten the matrix, and that's what I've done here. I've used a function called cormat and pmat in order to flatten the matrix and store it inside a data frame, and then output that as two of these columns. And if I go into the data preview, you can see that here's the result of my analysis, where depending on which variable I'm analyzing, you can see that I get the result of my correlation, whether it's a positive correlation between the two variables or a negative correlation. Now, these are the variables that are coming directly from the empty cars dataset. I've also made it a bit more clean. So I've used a simple calculation using Dundas BI's ability to cleanse the data, and I've just replaced, for example, here MPG with miles per gallon, CYL with number of cylinders. So that's another advantage of using this layer, is that you can also make the data more friendly in order to better understand and visualize it. Now, if I go and open this as a table, you can see that now it provides me with a better understanding of the data. So you can see that now I can see clearly the relationship between the horsepower and the displacement, for example. So higher the horsepower, more weight of the car you need. So it's a positive displacement. You can also say that the bigger the car, more number of cylinders it needs. And bigger the car, the less mileage it's going to give. So you have a negative correlation here. Similarly, if you take a look at the displacement here, once again, the higher number of cylinders means more bigger the car is and less mileage it's going to give. So you can see there's a positive correlation between the number of cylinders and displacement, and a negative correlation between miles per gallon and displacement. Scroll down, same thing with weight as well. So you have more power, more weight of the car means you need more power, there's a positive correlation, and less number of mileage and higher number of cylinders are required. So this way you can correlate the information, and this is a very tabular view. Now if you want to visualize it in a more meaningful way, you can also create a correlation chart such as this one. Now you can see that you can clearly visualize this in the form of a bubble chart in this case. So you can see that the size of the bubbles represent the correlation, the amount of correlation between the variables. Now, smaller the size, smaller the correlation, bigger the size, bigger the correlation. Now let's say you want to know, here it's not very clear whether which of these variables are having positive correlation or which of these variables are having negative correlation. In order to do that, I'm just going to switch into the visualization mode and add the correlation as a color variable. So once I add this, here you can see now that it's more clearly visible. Now you can see that if I hover over the darker colors, you can see that there is a positive correlation, and if I hover over the negative colors, you can see that there is a negative correlation. So visually now you can see which of these variables are having positive relations, which of these are having negative relations. So you can see that miles per gallon, it's having a negative correlation with the weight. So higher the weight, less mileage it's going to get, and higher the weight, more bigger the car is, as indicated by the positive correlation with the displacement. So that way you can correlate information between these different variables, and again it's using standard R library that in this case I've directly imported within the data cube layer. Now let's take a look at another example, and in this example I'm actually going to show you how you can visualize information based on the data coming out of Twitter. So let's say you have you want to analyze data that is coming out of Twitter. Here's an example where I'm actually visualizing based on the people who have tweeted, who have retweeted, based on the mentions that people have given. Here's a chart that I've come up with, and you can see that I can see the relations between different people and how strong those relations are. How this has been implemented is you can actually utilize the Twitter library. If I open the data cube, you can see that all you have to do is import the library. R provides you with the Twitter library here. All you do is authenticate your Twitter account and visualize it and get the result displayed within Dundas BI. Now let's say you want to see the number of tweets, the number of favorites, and you want to pull the Twitter handle. And in this case, let's say you want to see, based on the number of mentions that someone has done of your screen name or your friend's screen name, you want to see how closely those two accounts are related. You can all you have to do is drag and drop the full name of the person that you want to analyze the relation with, and you just drag and drop the name of the friend here. You can see that these are the people that are closely related with this person, and now if you want to understand the relationships between these people and how strong they are, you can visualize this in what we call a relationship diagram. Now as soon as I view it inside a relationship diagram, you can see that those relationships are more clearly visible. For example, you can see that this person is related to all these people, whereas this person is related to all these people, and you can see that based on the different nodes and different trees, who's the most influential person is, which person has more number of mentions. And if I add, let's say, the number of mentions here, you can see that not only the person who's most influential, you can also see based on the colors how many mentions took place for that particular person. And let's say you want to see who's influencing the most and how people are connecting. One of the other ways that you can do it is to shift here the friend's name to be the target. And as soon as I do that, you can see that the diagram itself changes, and now you have a more meaningful display of the data, or more clear view of the data. You can see that these three people are independently related versus these three people. versus these three people versus all of these people. So you can clearly see who the different clusters of the people that have been formed, who's most influential, who has more number of mentions, and if you take a look at the center, you can see that which of these people is the most influential and which of these people is the actual driving force behind this analysis that you have done. And if you want to see the strength of the relationships, maybe you want to highlight them, which of these are strongly related. You can also go ahead and in this case add a color rule. I'm just going to say that show me the strength of the relationships from light blue to black. As soon as I do that, you can see that if I zoom in, the lighter blue colors show me that this relationship is weaker as compared to this relationship, whereas the darker the color gets, you can see the stronger the relationship between those people. So this way, based on the tweets, you can analyze, um, uh, oof, how people are related with each other, what who's favorited the most, who to influence, who to go after if you want to use them for marketing purposes, for example. You can also, one of the other things that you can do is analyze text based on not just the Twitter data. Twitter is one of the key examples where you can perform text analytics on top of your data sources. So you can see, which are the keywords, which are the buzzwords that are coming out of your engagement with your customers, your audience. And let's take a look at one of the examples where you analyze not just the numbers that are coming out of your database, that are coming out of your data sets, but also analyzing the sentiment of the people, analyzing the buzzwords and the keywords. And again, once again, using the R library that is been provided to you. Here's an example where let's say you are managing a retail location and you have sent out a survey of to these different your customers and they filled out their comments based on different locations, and these are the comments that have been presented to you. You can see that some are positive, some are negative, and it's really difficult to go through each of the comments to analyze what people are feeling about your company or these individual different locations. In order to do that, you can actually go ahead and analyze the information. Here's an example where the same comments I've taken and presented them inside a chart like this. So you can see that based on the keyword, which of these words have been mentioned the most, which of these words have been mentioned the least. You can see that these are fairly neutral words. Some of them are positive, some of them are negative. How do you get this? Our language allows you to import or to use a library called text mining library that allows you to split the text into different keywords and then calculate the frequency based on the number of mentions of that word. How to implement that? Here's the example where once again, going back to the data cube, this time what I've done is I've connected the R analysis directly to my database. Here's the database, the SQL database, and here are the comments that we just saw. This is the row by row, line by line commentary, and using the R language transform, what I've done is use the library called TM, short for text mining, which allows you to utilize the functions that would calculate the frequency of the text that you are analyzing. So all I've done is use the corpus function to review the text that I'm analyzing, and what the corpus function also allows you to do is get rid of, in this case, the punctuation. You don't want any punctuation interfering with the analysis, nor do you want any white space, so also remove that. And I've stored all of that inside a use test function, document term matrix. So store all that inside a matrix and then calculate the frequency of these buzzwords that I want to be analyzed. And finally, I've just sorted them in descending order just to see which of these words are highly mentioned, which of these words are not mentioned that frequently, and then store all of that inside a data frame. And here's the result of it. See that D has been mentioned most times. Well, not very surprising, but here is the actual analysis. Store has been mentioned the most, find the second, and as you go down, once again, some of these are positive, some of these are negative. How do you visualize this? Once again, go into the data exploration, call the metric set, expand the data cube. This is the analysis that has been done. Drag and drop. Here are all the words that have been analyzed, and here are all the frequencies of all those words. That's it. And then what I'm going to do is just revisualize this into a different form, and then sort this. Just right click, sort based on frequency in a descending order. That's it. And if I zoom out, you get all the words that all the key buzzwords that you want. You can see which of these words have been highly mentioned, which of these words have not been mentioned that frequently. This is one way of presenting the information. You can also present the information in a what we call a tag cloud. Here's an example where the same information has been presented in a format like this. This is known as a tag cloud. And this has been implemented within Dundas BI using the d3.js library, which is an open source JavaScript library for data visualization. And using that, you can actually import any visualization that you want, which if you see that visualization is not being offered within Dundas BI, you can actually go ahead and customize and import your own custom visualization like I've done here and display it in whichever way you want. So all I've done is taken the same data set, the same data cube, and presented that inside a tag cloud like this, and that tag cloud has been implemented using the d3.js library. Now, we've seen a bunch of examples of individual analysis of these individual visualizations, individual charts. Now let's take a look at how all this comes together if you are building a dashboard, if you are analyzing a dashboard, how all this ties together with your analysis. Here's an example. So let's say you are managing all these retail locations within, in this case, a state, and you want to know, in this case, why the revenue for this particular region is down. You want to drill down within this region, and if you expand this, you can see that this particular city is having issues with the revenue. So if I drill down into it, get the financials here. Let's go ahead and see what the operations of this location looks like. So you can see that EBITDA for this department has fallen below the threshold. If I hover over this, you can see that throughout the year it's not done really well, and even in terms of the inventory, these are the three categories that have done really bad, as indicated by the red color. Now if I go into the customer experience dashboard, here's where you can really analyze the sentiment of the customers. You can see that in the customer scorecard how these majority of the categories have been rated poorly, as indicated by the red color, and these are all the comments that people have said about this particular location. And like I said, it's really difficult to go through line by line on what these people feel about your store in this case. And that's where the comment analysis comes into play. Here's this exact same textual analysis that we just saw based on the chart as well as the tag cloud here. And here you can see store has been mentioned the most. Next is fine, fresh, checkout, terrible. that's a negative sentiment. If we look at the tag cloud here, you can see clearly which of these categories, which of these words have been mentioned the most, which of these have been the least. And I've also performed some sentiment analysis based if any of these words fall under what in my opinion is a negative sentiment, I'd like to be highlighted in a certain color. This is the color red that I've highlighted this on. So you can see that people have said um, one of the buzzwords is terrible, disappointed, can't, rude, never. So immediately there is something going on within the store, and you'd like people to, you'd like maybe the manager of this location to immediately be notified. You can easily share this, export this into either an image, PDF, Excel, or PowerPoint, and quickly send it off to whoever is managing this location so that they can take immediate action and see what's going on with this particular location. So that's how you can tie your analytics, advanced analytics that you have brought in using the R language with your own analytics that you've done using the standard BI functionality that is offered within Dundas BI. So that brings us to the end of the presentation, and and right now what I'd like to do is open up the floor to some questions. So like I said, the questions panel is there for you to ask away your questions, and we'll tackle a few and go through your questions. And one of the questions that's been asked is, can you repeat the names of the sample data sets that I've used? So I've used a couple of data sets. One is IRIS, I-R-I-S. The other one is empty cars. These are all standard data sets that are available, and you can download that directly from the R, not the R website, but if you search for it, you can directly get those data sets. So you can either import them as a CSV file, or I just showed you, you can directly use the data function to load the data set directly. So when you install R, all these standard data sets do get installed within your R server, and you can use the data function to import the data directly from them. Now, the other question that's been asked is there any limitation for the libraries that can be used within Dundas BI? The answer is no. Like I said, all Dundas BI does is executes the script that you've seen. Executes the script that you've written onto the R server. So the only limitation that you will face is with whatever limitations are offered within R. That's all. You can import any library that you want. You can install, like one of the example I showed you is directly installed the library within R itself, within Dundas BI. So you can also do that. Most commonly, you would first import the library within the R server and then just call the library within Dundas BI. But if you do want to install it directly, you can also do that. So yeah, there is no limitation. Anything you can do in R, you will be able to do in Dundas BI. Yeah, one of the other question is, can you use R in Windows Server? Yes, you can use R in Windows Server. One of the things that is recommended that I've come across is that the recommended way to use this is to use R in Linux Server. Simply because there are more functionalities that are offered when you use R in Linux, but if you want to use Windows Server, yes, you can. There is no restriction on that. How do we link our server within Dundas? Now, if you go into the config file, all you do is point Dundas BI to the R server. If you go into the admin panel, search for R serve, there are three settings. One is the server name, the other is port that's being used, and I forget the third one, but all you do is just point those settings to the R server, whether it's installed locally on your machine or if you're using a dedicated server to that. So it's all in the config file, which you can find if you go into the admin section of Dundas BI. Can you use or display R built-in visualization tool? I'm assuming that you're talking about the ggplot function. The answer is no. That ggplot is very specific to plotting within R, or even if you're using RStudio. What Dundas BI or dual use Dundas BI is to use the visualizations that are offered with Dundas BI to visualize the data. So you don't have to use ggplot. It's a very static library. And most of the charts that you would be plotting within R, you can plot within Dundas as well. These are just standard charts. Like I said, if you have any very specific complicated chart that you'd like to plot, you can always use the D3 library to import the visualizations. And someone's pointed out that displacement refers to the surface area of the pistons and not the vehicles. So thank you for that. Not very, as you can see, I'm not very proficient in my knowledge of cars, but thank you for that clarification. All right. Keep the questions coming, guys. Right. Is there any plan to have the same kind of functionalities with Python rather than R? Not sure about that. To double check with our product development team. But if you do want to implement Python as well, instead of using R, it can be done within the data cube. You just need to use the API and create your own custom transformation that executes the Python script. And that's all what the R transform is doing. It offers the interface to execute the R scripts that talks to the R server. So if you want to execute Python or any other language, all you do is use our fully flexible and full API to create your own custom transformation and execute whichever language script that you want. All right, so if there are no more questions, we can proceed. So once again, thank you for all your questions. Thank you for attending. If you have any other questions or if you need any clarifications or you want to try Dundas BI yourself, feel free to request a demo or talk to your account executive to learn more about it. We do have free online trials and full product downloads. And if you want a live demo of the product, then feel free to reach out to us and we'll be happy to present it to you. So once again, thanks for attending and have a great day and take care. Goodbye.